Hello everyone and welcome to section 3 of the Mathematical Proofs lecture series. So we are going to begin section 3 and we will be looking at trivial, vacuous, and direct proofs, as well as different problem settings or conditions. So we will now be starting to get into the proof techniques. That will be the core of this lecture series. So before we get into learning the first three proof techniques, trivial, vacuous, and direct proofs, we will first look at some important math terms and some math writing tips and techniques for this section. So let's first look at some math terms to understand. And the first one is axiom. And an axiom is a true mathematical statement whose truth is accepted without proof. And then another term to understand is theorem. And what is a theorem? It is a mathematical statement whose truth can be verified. And then another term is a corollary, and that is a mathematical result that can be deduced from an earlier result. And then the last one to understand is lemma. And a lemma is a result that is useful in establishing the truth of another result. So these four terms are important to understand when we work on proofs, because some of them are useful in helping us write a proof, and some of them, like corollaries, come from proofs. So you will see some application a little bit later of these terms. So now let's look at some math writing tips. So these are some tips to learn before writing proofs. So, symbols never start a sentence with a symbol. And also keep symbols separated by words if possible. So, an example, just say we have some words right here and then we show some symbols, then A, B, R, even. Well, a better way to write this would be to rewrite it as, just say these little squiggles are just words, and then we write it as A and B are even. That way we separate the symbols. Now, I will say that sometimes when we are identifying what a symbol is, we may combine them using a comma. So if we were to say something like this, say that we're specifying they're both integers, then this kind of writing can be used. So this isn't an always, never start statement. But let's say it's sorry, I'm looking at the wrong sentence here. Wait, no, we're actually good. Yep. Yeah, because that's talking about starting a sentence. I was thinking about the second one. Keep symbols separated by words if possible is a good way to describe this. Because they never have to be separated by words. But sometimes it may be better to keep them separated. All right, so another writing tip. Don't use logical symbols except when discussing logic. So, I'm sure you may recall some of these if you watch section 2. We have an implication. We have for all, there exist, the quantifiers, by conditional symbol, and etc. Those kind of logical symbols. Avoid writing symbols in theorems. So if you're ever writing a theorem that you're going to write a proof for, just leave symbols out of it. Save those for when you're writing your proof. It's better to explain the meaning of symbols that are introduced. So an example would be if we introduced x, we could say let x be an integer. Kind of like what I did up here with these symbols. We're saying we could define a and b to be integers. Another tip. Don't mix words and symbols. And an example would be every integer less than 0 is negative is better written as every integer less than 0 is negative. Another tip is don't use symbols that are often used for other math properties. So, an example would be f is often used for functions like f(x), so avoid using f as a symbol. All right. Now, those are some good math writing tips. Now, let's go into some writing techniques. So, one thing when writing math proofs, an important technique to consider is simply think of your audience. Think of who you're writing your proof to. Important technique is to keep your words in a proof to a minimum. The logic and steps you take should explain more to a reader than words can. So basically, you just want to write a proof that is basically it's straightforward to understand. You don't have extraneous details that aren't necessary. You want to write a proof that if someone were to read, we'll just draw a little guy with a face here. You want to write something that if someone, whether it's teacher, mathematician, or even someone or engineer, someone wanting to see what theorem or proof you've come up with, can read and they can say that if they read your proof, it was pretty easy to understand, straightforward, they can read it and say, I liked this, or something like that. I mean, realistically, they're probably not going to say that, but I think you might could understand the point that I'm trying to make. You just want to write a proof that that is straightforward, the logic can be understood, and isn't harder to read than it needs to be. So another technique is to use math words and phrases. Some examples are let, clearly, obviously, every, then, hence, therefore, etc. And of course, like, these words have different uses based on where you are in your proof. And this is obviously a short list too, so you can look up some more to learn more math words, and you will see some in these lectures. So you'll see how we use some of these words and phrases as we begin writing proofs later down the line. All right, another technique. This is a new phrase to understand. That is without loss of generality. And I'm going to highlight this because this phrase is used a lot. And we will probably work some examples where we will use it too. Just get all these words nice and highlighted. All right, so what does this phrase mean? Well, this is sometimes abbreviated as WLOG, WOLOG, or WLOG, and this is used to indicate when a proof of two situations are similar. So this means we really only need the proof of one. All right, so now let's look at some proof writing let me do proof writing tips, because techniques is technically everything we'll be going over after this section, or most everything we'll be going over. So some proof writing tips is to include a section title and symbol or indicator at the end of the proof. So this is real similar to when we did the examples in section 2, and we would include a section title for the solution and then draw a symbol to show the conclusion of the solution. So this is the section title that I will be using in these lectures, and what you will see often. Just simply proof, and then most proofs are often use a square, usually a filled in square, to indicate the conclusion of it. However, sometimes, albeit it's not as often as the square symbol, sometimes proofs conclude with this statement, QED, which is an abbreviation for quod erat demonstrandum, which is Latin for which was to be demonstrated. These are not, I guess, so to speak, professional closings, but they're fun closings. So we have OBIDI, OBIDI, which means, oh boy, I did it. So this was a phrase that was mentioned when I had my Intro to Concepts of Math proofs class. And Dr. Hetzel, if you're ever watching this, just want to know you inspired me to do these lectures. But he mentioned this when he was teaching us proof writing, and said that he had a professor who used to like to write that phrase for fun at the end of his proofs. Or this is one that I came up with. ATWF. So, which stands for awesome. That was fun. So, both of these are obviously, of course, not professional conclusions, but they are fun to use. They are just really, really cool and fun closings to use for, having fun with math and proofs. And may use some of these when we write some of our proofs occasionally. But if you're wanting to write articles and stuff to be submitted or research papers, they're probably better to avoid using them. But yeah, so with all that being said, that's the conclusion of the first section. So we are ready to start learning our proof techniques. So proof mobile is ready to go. Alrighty. Hey guys, so thank you for watching this video, and I will see you in section 2 where we will start covering our proof techniques.